you could draw a triangle. If you know tangent, you know the opposite side, you know the adjacent side. You can use Pythagorean theorem to find the hypotenuse, and then you could use that to find cotangent and secant. But using the identities, cotangent is the easier one. If I know tangent, and I know the relationship between tangent and cotangent, so going back over here to my identities, the one that involves tangent and cotangent, so that tangent is 1 over cotangent, or cotangent is 1 over tangent. We can use either one of those for this. If I do 1 over a fraction, I've got to flip the fraction and multiply it by 1. So when you're doing reciprocals, you can just flip. So if I know tangent is 1/3, cotangent has to be the reciprocal of that, which would be 3 over 1, or just 3. So cotangent is 1 over tangent, or 1 over 1/3. And remember, this is dividing by a fraction. You've got to flip the bottom fraction and multiply. So it would be 1 times 3 over 1. So just remember, you need to flip it. So now I know tangent, I know cotangent, and I need to find secant. So I want to look back at my identities, and eventually I want to remember the identities. But I know tangent, I know cotangent, I'm looking for secant. So I'm just going to go through my formulas here, looking at the ones that involve secant, and I also want them to involve tangent or cotangent. So none of these reciprocals are going to work, because the ones that have tangent and cotangent don't have secant. The ones that have secant don't have tangent or cotangent. Looking at the quotient identities, they don't have any secants there, so I can't use them as they are. Looking at the Pythagorean identities, I see that the second one here involves tangent and secant. So you can see that since I know tangent, if I plug tangent in there, then I only have one unknown, so I can solve for secant. Use the Pythagorean identity that said 1 plus tangent squared equals secant squared. This is what the identity says. So I'm going to take what I know already and put it in here, and then solve for secant. And it might be easier to see it this way. All right, so we know tangent of this theta is 1/3. That was given to us in the problem. So I'm putting it here. Tangent is 1/3, so tangent squared is going to be 1/3 squared. So this right here is tangent squared. So now the right side is just numbers. We can simplify that. I'm not doing anything on the left just yet. But if I square 1/3, then it becomes 1 over 9. If I want to add that to 1, then I need a common denominator. So how would I rewrite 1 with the denominator to match 9? If it's just 1, denominator is just 1. If I want it to be a 9, I can multiply by 9 from the top to the bottom. So it'd be 9 over 9. So that's still equal to 1. But if I write it as 9 over 9, I can add these together. So secant squared is equal to 10 over 9. And so we're almost done, but not yet, because the problem just asks us for secant. My secant squared. So just like if these were x's, if you knew x squared and you wanted x, you take the square root. So if I know secant squared and I just want secant, I want to take the square root on both sides of the equation. So now you might remember from algebra that when you take the square root, you got to be concerned about, is it positive or is it negative? That's why we put that plus or minus in there. We don't have to worry about that here, because they're telling us in the problem that theta is an acute angle, meaning that it's less than 90 degrees, meaning that on my unit circle it's in the first quadrant, and all of the trig functions are positive in the first quadrant. So this is going to be positive as well. So if I take the square root of secant squared, now it's just secant. If I take the square root of 10 over 9, remember with the fraction, you can take the square root of the top and the square root of the bottom. We don't know the square root of the top, so we can leave it as square root of 10, but the square root of the bottom is 3. This is the same thing that we would get using a triangle. but you have to be able to draw the triangle. Show you the triangle version. So same problem, we know tangent was 1/3, and we want to find cotangent, and so with the right triangle, this is the way I'm always draw my right triangles. If I call this theta, so given tangent, remember that tangent is opposite over adjacent. That's going to tell you how to label your triangle. So this side that's opposite theta is over here. That's got to be equal to 1. Adjacent to theta is this one down here. That's got to be equal to 3. So then do we remember how to find the other side of the triangle? Using a squared plus b squared equals c squared. Remember, c is always the long side, so this would just be 1 squared plus 3 squared equals hypotenuse squared. So that's 1 plus 9. So c squared is 10. I just want c, so I'm going to take the square root. Square root of 10 is equal to my long side here. So if I know all 3 sides of the triangle, I know cotangent is the reciprocal of tangent, so it's adjacent over opposite. Adjacent over opposite would be 3/1. So it is 3, just like we found before. Secant is 1/cosine. Cosine is adjacent over hypotenuse, so this would be the reciprocal. I'm taking adjacent over hypotenuse and flipping it over, so hypotenuse over adjacent. This is the reciprocal of cosine. All right, so that's the square root of 10/3. So if it's not specified in the directions, you can use any method that you want.